Hello, everyone. So today we shall be diving into questions and answers on electromagnetic induction, basically on transformer. All right, let's dive into this. Example one. It says a transformer is required to give 120 volts from a 240 volt mains supply. If the primary has 5,500 tons, how many tons has the secondary? Alright, let's write our parameters. So firstly, we are given the primary voltage to be 120 volts. Okay, and that is it here. The EMF of the primary circuit is 200. Sorry, from a 240 volts. So this is our main supply here. See the primary voltage. So we have our primary voltage to be 240 volts. Now the supply voltage is actually 120 volts. The supply voltage is the secondary voltage. That's 120 volts. But the point from where the voltage is drawn from in the primary voltage, that's 240. Now, if the primary has 5,500 tons, that is, if the primary circuit has this number of tons, that means our MP, number of tons on the primary circuit, if it is 5,500 tons, then how many tons do we have in the secondary circuit? They are unknown, the NS. So the formula to use is the ratio of the secondary voltage to that of the primary voltage is equal to the ratio of the number of turns of the secondary circuit to that of the primary circuit. So when we do this, now we substitute our value. Our secondary voltage or EMF is 120, so we have 120 here. Primary voltage is 240 volts, so we have 240 here. Now our secondary number of turns in the secondary circuit is unknown. At our NS here, our MP is given to be 5,500. So when we simplify here, our NS will be 2,750 tons. Okay, so for the fact that we have a lesser number of tons in the secondary circuit than the primary circuit, it shows that this transformer is a step-down transformer. All right, now let's take another example. Here it says the current in the primary coil of a transformer is 2.5 ampere. If the coil has 50 tons and the secondary 250 tons, calculate the current in the secondary coil. Neglect energy losses in a transformer. Okay, so we write our parameters again. The current in the primary coil is IP, so our IP is 2.5 ampere. Okay, the number of turns in the primary coil is 50, so our MP is 50. While secondary coil has 250 turns, so our NS is 250. So we are meant to calculate the current in the secondary coil. That's our IS is unknown. So using the formula, the ratio of the primary current to that of the secondary current equals the ratio of the number of turns in the secondary circuit to that of number of turns in the primary circuit. So using this formula, we substitute the value of our IP, which is 2.5 here. Our IS is the unknown one, so our NS is given to be 250. Our MP is 50. And so when we cross multiply to determine the value of IS, we have it to be 0.5 ampere. Alright? So another example. Here we have a 95% efficient transformer is used to operate a lamp rated 60 watts, 220 volts from a 4,400 volt AC supply. Calculate 1. Ratio of the number of turns in the primary coil to the number of turns in the secondary coil of the transformer. 2. Calculate the current taken from the main supply. Okay, now let's take out our parameters again. In this case, we are given a 95% efficiency. So efficiency here, E, is 95%. Now, the transformer is used to operate this lamp that has this rate. Now, the rated lamp is the secondary power. Okay, so the rated lamp has the power of 60 watts. So our secondary power is 60 watts. Also, the rated voltage is also secondary voltage. So that is our ES is 220 volts. Secondary voltage is 20 volts. Now, the main supply is always the primary supply. So we have a primary voltage of 4,400 volts. Now we are made to determine the ratio of the number of turns in the primary coil to that of the secondary coil. That means MP to NS. It's unknown. Secondly, we have to determine the current from the main circuit. The main circuit current is already the primary current, and it's also unknown. So for the first one, using the formula, the ratio of the number of turns in the primary circuit to the number of turns in the secondary circuit equals the ratio of the voltage of the primary circuit to that of the secondary circuit. Okay, now since we are made to find NP over NS, so our NP over NS equals EP over EX, right? Now our EP is given, that's 4,400, and our ES is also given 220. And when we divide these, the ratio of the two turns is 20. Okay, second question is to determine the current from the main supply. That is our primary current. Now, the formula for that is primary current equals the product of the secondary power and 100 all over the efficient multiplied by the primary voltage, right? So the secondary power, which is 60 watt, is substituted, 100 is there. Then the efficiency, which is E, is 95, multiplied by the primary voltage, which is 4,400. So simplifying all of these, we have the primary current to be 0.01435 ampere, or in standard form, you can also say 1.435 times 10 raised to the power minus 2 ampere. Okay, let's take another example again. Here it says a transformer supplies 12 volts when connected to a 240 volt mains. If the transformer takes 0.120 ampere from the mains when used to light a 12 volt 24 watt lamp, what is its efficiency? Right? So we have to determine the efficiency of the transformer now. Now let's write our parameters again. Since the transformer is supplying 12 volts, it means that the secondary voltage supplied, our ES, is 12 volts. Okay, since it's connected to a main supply, that means the primary voltage is 240 volts, that's our EP. And then since the transformer is taking this amount of current from the mains, that means our primary current, that is IP, is equal to 0.120 ampere. Also, the light is connected at the secondary circuit, so that means whatever is in the secondary circuit, okay, has all the secondary attributes. So for this 12 volt now, it's already supplied by the transformer, so it's taken to be the same thing. The transformer supply 12 volt and the lamp is rated 12 volt. So our secondary voltage to remain 12 volt. Then our secondary power is 24 watts. Then the efficiency is the unknown. Now using the formula, efficiency equals to, usually the original formula for efficiency is output power over input power multiplied by 100. Now our output power here is taken to be secondary power, while our input power is taken to be primary power, the primary power or primary circuit power. So in this case now we have our output power to be, we have our efficiency to be secondary power, which is PS, all over primary power, which is PP. But PP now is the product of IP and EP, right? So secondary power over primary power times 100. Now we have our PS to be 24 watts, so we substitute that value times 100. Our IP here is 0.120, we substitute it again, then multiply by our EP. Our EP is 240 volt here, we substitute the value here. Simplifying all of these, we have our efficiency to be 83.33%. Yes, let's take the last example for today. It goes there's a transformer which can produce 8 volts from a 240 volt AC supply has an efficiency of 80%. If the current in the secondary coil is 15 ampere, calculate the current in the primary coil. Okay, let's take out our parameters again. Yeah, this transformer produces this 8 volts. What that means is that the secondary voltage, the supply voltage is 8 volts. That means our ES is 8 volts. From the main supply is always the primary. So we have our primary voltage to be 240 volts. So EP is 240 volts. And then the efficiency of the transformer is 80. So our capital E is 80%. Now, if the current in the secondary coil is 15 ampere, that means our IS secondary current is 15 ampere, and we are meant to calculate the primary coil, which is IL, or which is IP. This ought to be IP. This ought to be P primary coil. That's the unknown. Okay, that's the unknown. So now using this formula, the IP equals IS times EH times 100 all over E times EP. Okay, so our IS, we have it to be 15 ampere, we substitute the value. Our ES is 8, we substitute the value, okay, of 100 is there. Then our efficiency is 80, so we write it here. And our primary voltage is 240. To simplify all this, we have our primary current to be 0.625 ampere. All right, so this is where we shall be drawing the curtain for today. Thank you for listening. Bye for now.